Hey, what's up, everybody? We're going to be taking a look at how to create the Automata box. We're going to be doing a little bit of top down with this. A good majority of this is going to be top down. But we're going to be making the box that comes with the PLTW Automata kit. You're going to see in that kit there's going to be 5 different pieces that students are going to be gluing up, and they're going to be creating this box. And then within that box, they can assemble their axle and followers and cams and all that. But right now, we're just going to be focusing on how to really build this box in a top-down approach, but at the same time using actual parametric modeling. All right. So all the dimensions you're going to be seeing once again are coming from the kit that comes with PLTW. All right. So at this point, if you're a student in my class, you've already created a sketch, a multi-view sketch, all the dimensions that they're going to have to know for all the parts, as well as the different holes, the thicknesses of the material, the rod guide holes, all this stuff that's already been custom made for our class. So all this information is in their engineering notebooks. All right, so what we have to do first is we have to set up our parameters. So what I'm going to be doing is coming here to modify, going down to change parameters, and you're going to see we have 3 different things here. The one thing that we're going to be focusing on are the parameters that we are going to be setting up. Those are called user parameters. So when I hit the plus sign, you can see how I can start, creating these parameters. So the first thing I'm going to do is I'm going to type in width. Okay, so we're going to set up the overall width of this box assembly. Okay, and the overall width is 5 inches. So I'm going to type in 5 for my expression, and then a little comment down here, we're just going to say that this is the box width. Okay, so I'm going to go ahead and say OK. Once we do that, we can now see that all those have been placed in our parameters dialog box. Let's keep going. Okay, so we have our width. So let's go ahead, let's go with our height as well. Okay, and when we measured our height, we found out that that was the assembly. It was 4.5. So I could easily go out here and type in 4.5. But the thing is, in the end, I want a box that's going to be able to correct and fix itself. So what we can do is, after we have this thing assembled, it's going to have some AI, some artificial intelligence to it with these parameters. So it's going to be able to shrink and expand and move around and thicken and all sorts of stuff. I want to keep this having some proportions to it. All right, so I don't want to put in an exact number here. Instead, what I'm going to do is I'm going to be thinking about percentages. So we measured this in real life, and the height of this box is actually 4.5 inches. So if I bring up my calculator here, if we took 4.5, we divide that by 5, which is going to be our width, we can see that our height right now, currently, the proportional, the proportion of it is about 90% or 0.9. So I'm going to say, hey, I'm going to take my width, and I'm always going to multiply this by 0.9. I want my height to be 90% of whatever my width is. We can see that my value is 4.5. So I'm going to say, hey, my box height is my comment on this. So I'm going to go ahead and say, okay. All right, we have our height established. I'm going to add a new one. This is going to be our depth. So in real life, our depth is 4 inches. So if we bring out the calculator, we took 4 divided by 5, which is our current width. We can see that right now our depth is about 80%, okay, of what our width is. So I'm going to say, hey, take our width and let's multiply that by 0.8, okay, and then my comment on that is going to be, this is my box width. So I'm going to go ahead and type that in. All right, so width, height, depth, we got those all taken care of. We're going to add a new user parameter on this one, and we're just going to call this one THK. This is going to be the thickness of our MDF, which makes up our panels for our box. Okay, the expression on this, we want to lock that down. I want to bring that at 0.25, which is what it is in real life, and I'm just going to say that this is going to be my box panel thickness. Okay, so that is not referencing anything. I want direct contact with that so I can change that up. All right. All right. So when we create our automata, we're going to have an axle that goes through the center of this, and that axle is going to be spinning, and that's what's going to be spinning our cams, which is going to be moving our followers, which are connected to our follower rods. Okay. So the axle that I use in my class is a round dowel. All right, and it has a diameter of 0.25. So what I'm going to do is I'm going to go ahead and add a new parameter, and I'm going to call this axle hole DIA. So that's our axle hole diameter. Okay, the expression on this is we're going to lock that in at 1/4 right now, 0.25, and then we're just going to put in our comment, which is axle hole diameter. Okay, so I'm going to go ahead and say OK on that. Now, the follower rods that we use in our class are 1/4 inch square dowels. So if you know anything about this, obviously we've got a square follower rod that's going to have to go down through a hole, which is going to be the top panel of our automata box. Now the issue is it's really difficult to actually create a square hole or cut a square hole in MDF. So what I've done is I've created bushings that are cylindrical, and then there's a square hole in the center of them. So all we have to do is actually drill a hole, and we can push those in, glue them into the actual top panel of the box. All right. So what we have to do now is say we want to put our rod guide hole DIA, and that is actually 1/2 inch. Okay, those are those little 3D printed parts. They have a 1/2 inch diameter. And now we're going to say that this is rod guide hole diameter. Okay, so that is done. All right, so we have what, 6 different parameters that we've already set up. So I'm going to go ahead and say okay. All right, so now that we have that done, this is probably a good time to go out here and do a save and just call this like, your first, last, initial automata project. Because remember, this is top down. Everything's going to be right in this one design. It's going to be kind of cool. All right, let's get going. So let's go ahead and create a sketch. So I'm going to be, even though I'm using the top-down approach to Fusion, I'm going to actually be building this physically from the ground up. So we're going to be starting with our bottom piece. So I'm going to be starting here with our work plane that's on the bottom. I'm going to use my rectangle, start it here at the origin, just create my rectangle. I don't care the size. And now this is when I can start adding dimensions. Okay, I'm going to go ahead and put in my dimension for my width. And since I've already set that up in my parameters, all I have to do is type in width. Okay, so I can see that my width is 5 inches. And if we go back into parameters, we can see that my width is 5 inches. That's why it's showing up there. And we can see that fx, which is a function. Okay, so let's go ahead and now let's add a new dimension. So we're thinking about this, we are looking at the top of this. So this would not be the height, this would be the depth. So I'm going to type in depth. Okay, we can see that is 4 inches. Okay, now we can go ahead and finish that sketch and look at this in the home view. All right, so now I'm going to extrude this up. Now when I go to extrude this, we have to remember we have a parameter for thickness. This is the thickness of our MDF, our medium density fiberboard. Okay, so before I accept the extrusion, this is the most important thing to remember when you're doing top-down modeling. We are not creating a new body, we are creating a new component. You have to pick new component before you get out of this extrusion. So go ahead and say okay on that. All right, so the one thing that we have to remember is that, with this new component, we have to remember it's not grounded, okay? So the first thing we're going to do is come over here to that new component we have created. We're going to come up here and go to ground it. All right, now I try moving it, it's not going anywhere. The other thing is it's given us kind of a bad name. I mean, it's just called component 1. That's very generic, general, it doesn't do a whole lot for us. So what I'm going to do is a slow double pick on top of this, and I'm going to give it an actual name. So I'm going to call this box bottom. All right, so our box bottom is there. It is grounded, and we can see it's gross and ugly. It's gray. This is not what it looks like in real life, because in real life, this is made of MDF, medium density fiberboard. So that's what we're going to apply as a material. So I'm going to go to box bottom. Sorry about that. So what we're going to do is apply a material, which is MDF. So let's right click on it, and let's go up here to physical material. And if we cruise down here through our different materials, we're going to see that wood has a folder. If we come down a little bit more, we can see that MDF is one of the choices. So I'm going to go ahead and drag that on top. The issue is, believe it or not, MDF does not have an image loaded, which boggles my mind, because if we look at appearances now, so let's right click on box bottom and come up here to appearances. If we do a search in our library for MDF, we can see that there is one here with the Fusion 360 appearance library. Drag and drop it on top, and that does look like MDF. So unfortunately on these, you have to apply the MDF material separate and then apply the appearance. But it does look like MDF, so I'm happy. All right, so we have our box bottom done. So now what we're going to do is we're going to start building up from there. So we're going to start building our sides next. Okay, so I'm going to go ahead and create a sketch, and I'm just going to pick on this face right here. Okay, I'm going to create a rectangle, starting it from the top left-hand corner of this current panel. I'm going to go ahead and just draw the rectangle out. I can now start applying my dimensions. So the easy one to remember is, well, if we're looking at the right side of this, well, this would just be simply worth our depth. Okay, and it's going to go back to where it belongs. Okay, now a lot of people would look at this and they would just automatically go out there and say, well, I just want the height, and apply the height to our dimension. Well, the thing is, we have our side piece and it is sandwiched between the top and the bottom. The top and the bottom pieces have a thickness of 0.25, so it's not really going to be height. So we can go ahead and we can make this happen by coming out, putting in a dimension, and we're going to say, you know what, whatever the height is, go ahead and subtract the THK, which is the thickness of the material, and another THK. And we hit enter on that, and we can see that is 4 inches tall. Okay, so we know that the thickness of our bottom is 0.25. The thickness of our top, when it gets there, is going to be 0.25. So this would be a total overall height of 4.5, so we are correct. I'm going to go ahead and finish the sketch. Look at this in the home view. Go into extrusion, pick the profile, and I'm going to send it this way. So you can see when I'm sending it that way, it's a negative number. So we have to remember to put in negative first, and now we're going to say this is THK. All right, we're also seeing that this is joining to the bottom. All right, so don't forget, always in your operation, you have to switch this to new component, and we're going to say OK. All right, so this looks great. All right, it looks exactly where it's supposed to be, but the issue is we built this in place. It has not been joint, is not been applied a joint to it. Okay, so I'm going to go ahead and undo that, and let's go ahead and show you an easy way to put that in place, and that's by coming up here, going to Assemble, going to As Built Joint, and what we're going to do is just say, hey, keep that right where it's at, okay, and we're going to reference this piece here. We can hit the play. All right, we can see that that rigid joint has been attached to it, and say okay. So we're not having to worry about joint origins. We're just saying, hey, exactly where it's at, keep it right there, okay, and apply a rigid joint. Kind of cool, right? All right, so obviously this is giving us another bad name, just component 2. That's not very descriptive. So let's go ahead and just type in box side. Let's rename that. And then obviously we need to right click on this, add some physical material to it. Okay, we still have the MDF from last time. We can drag that over. And then come here to my box side, come up here to my actual appearance, find my MDF, and let's just drag that on. Okay, so we have our side developed. Okay, so our side is not just its side, just like it's shown, all right? Remember, we have a hole that's going to have to go through that for our axle, okay? So we have to drill a hole. So I'm going to come down here to my box side, and it's just something I like to do. If I'm working on a particular piece, I'm just going to make that piece active, or that component active. So I'm going to come in here, and you're going to see a little radio button here next to my box side. If I pick on that, we're going to see that everything goes transparent. The only thing I'm talking to right now is just going to be that part. Okay, so once I've done that, I'm now going to come out here and say, I want to place a hole on this face. Okay, so there's some references that we have to know here, and you're going to have to look at your sketches that we made in class, the multi-view, to get this next information. But basically, this hole needs to be back halfway. All right, so this total distance we have here, going from front to back, that's what its depth would be. So I'm going to say, you know what, this hole is going to be our depth divided by 2. We want that hole to be dead center. Okay, and now I'm going to come up here to the top. I'm going to pick this top reference edge. And I'm going to say, you know what? I'm going to put this in parentheses. I'm going to say, I want this to be the height, okay, minus our thickness and another thickness, parentheses, and then divide that by 2. All right, and that should be putting it dead center in that face. Okay, my diameter is going to be my axle hole DIA. Right? That's what that diameter is going to be. And then if you think about it, the depth on the hole itself, we can just make it equal the thickness of the material. So I can type in my THK. All right, so it's going to be my depth divided by 2. Okay, we're then going to be taking my height, subtracting thickness and thickness again, and then taking that, dividing it by 2. Okay, our thickness is going to be our hole depth, and then our axle hole DIA is going to be our diameter. We say okay on that. Okay, there's my hole. And I'm going to go ahead and just switch this back into the assembly mode by hitting the radio button. It's right here. Okay, and I'm going to go ahead and just look at this from the right side. And I can see that hole is like dead center of that side panel. So we're doing great. All right, so now that we have our side done, all right, we have to create another side. All right, we got to keep building this up. So instead of just going out and creating a whole new side, it's already done. We have the component. So how about we just right click and do a copy on this, and then right click out here in space, white space, and hit paste. Then we can push this with the triad and we can say okay. All right, at this point, you should know how to do this using our joints. Okay, coming in here, finding the correct joint origin. If you need to do the filter, you can hold control. Okay, we're going to place that right where it's supposed to go. Drop that right in. We can see that's a good rigid constraint. Okay, we can animate it if we want to. Let's go ahead and say okay. So right now we're back into the home view. We can see we have our bottom and our two sides. Now we're going to go ahead and build the top. All right, so I'm going to come up here, create a new sketch. I'm going to just be on this very top surface. I'm going to pick on it. And now what we're going to do is we're actually going to reference existing geometry. So in order to do that, I'm going to use create, go to project, and then for this one, I'm just going to come right here to this top left-hand corner. I can see at that point's there, so I'm going to select it and then pick on this point as well. All right, this is when I can go ahead and just use rectangle, start at the top left and take it to the bottom right point that I just established. I'm going to finish that sketch. I'm going to use extrude, and now I'm going to be picking this face and this face. Make sure you're selecting all the parts of that to make that profile. Okay, I'm going to go ahead and drag this up. There's some weird things happening. Why? Because we have not switched this to new components. So go ahead and do that. And now it's going to be asking us what our distance is. And of course, that's going to be THK, our material thickness for our MDF. Okay, so once again, it's new components. I'm going to say okay. And once again, remember that's still not attached. So we do have to go out there, go into assemble. Okay, find our as-built joint, pick the top, pick a side. Okay, hit the play button to see if that's actually rigid, and it is. We say okay. All right, we got to get that renamed. So now let's go and rename that. That's obviously going to be our box top. And now our box top has to have physical material. So in our case, that's going to be MDF. We can drop that on. Okay, and then we have to do our appearance. That's going to be MDF. Let's drop that on and hit close. All right, so this is the point when I'm having my students look at our sketches, our multi-view from the day before. So obviously our top is just not going to be a plain piece, all right? If it was, we could have just simply copied our bottom and brought it up, but in our case, our top actually has holes drilled into the top. And the holes are going to have the rod guides, and the follow rods are going to be sliding through the rod guides. So we have to place those holes into the top. So I'm going to come here right to my box top, hit the radio button just to make it active, and now we're going to get started. So I'm going to go to my hole feature, come right here to the top, pick on that face, and now I'm going to come out here and start getting my reference geometry. So I'm going to start with the easy one. Start here at the front. It's going to go half that distance back. So that's my depth, and I'm just going to divide it by 2. All right. So now I'm going to go ahead and switch to this reference edge. So in my student sketches, all right, we said that the X dimension on this hole, how far it's going to be from the edge, was 1.25. I'm not going to apply just 1.25 in this case because I want this to be proportional in case we do actually scale this up. So instead of this, the width being 5, let's say we increase it to 10. I don't want that follow rod to be all the way over, or the rod guide to be all the way over against the edge 1.25. If we have all that room, we're going to keep it proportional. So once again, I'm going to do the scaling thing. I'm going to come here to the calculator and say, all right, this is 1.25. This is what I want it to be. But I'm going to go ahead and divide that by 5, which is what it is, the existing. We can see that that's 25%. So what I'm going to do is I'm going to say, hey, I want this to be worth my width multiplied by 0.25, which is 25%. Okay, my hole diameter in this case is not going to be my axle hole diameter. This is going to be my rod guide hole DIA. And then my depth on this is simply worth the thickness of my material. All right, so we've got that. We got our depth divided by 2, our width times 0.25, our rod guide hole diameter, and then we have our thickness for our depth. Let's go ahead and accept that. Okay, and now we're going to do the same exact thing again. So our hole comes in. Okay, our first reference, this is going to be depth divided by 2. Okay, and then from this edge, this is going to be my width multiplied by 0.25. Okay, and then my depth itself is going to be the thickness of our material, which is our MDF. Okay, and then this is going to be our rod guide hole diameter. Okay, so we have that. Okay, we're going to go ahead and say okay on that. And that hole is now in. Now I'm going to be switching back over into my assembly environment. All right, so we're looking pretty good here. All right, so obviously I would say go ahead and switch to the home view. Make sure you understand where your actual front is. This can get a little bit confusing if you think about it. So just go to hole first and then just slightly flip this over And now let's go ahead and create a sketch on this back face here because we need to obviously build that back part. Okay, so I'm going to go into create, go into project again, and I'm just going to sneak right in here and I'm going to look for that exact point at that corner and then this point right here at this corner. All right, so we have those two reference points with our existing geometry. And just like our top, we're going to go ahead and just create a rectangle that's going to go from the top left to the bottom right, just like so. We're going to finish the sketch, go into home view, and now let's go ahead and extrude that. So I'm going to extrude this profile only. I'm going to shoot this in, but please notice it's indicating that that's a negative. So we're going to say, hey, this is a negative THK for thickness of our MDF. And now let's switch this over to new component. Okay, don't forget the new component. Let's say okay on that. Let's go into assemble, go into an as-built joint, pick that back piece, and it does not matter which one you pick from here on out. Okay, we're going to go ahead and get that rigid joint. Okay, we're going to go ahead and say okay. Obviously, this now needs to change. This is going to be my box back. And now we need to come in and go into our physical material. Okay, we need to apply our MDF to this. And we need to go in here and go to appearance and put our MDF on that back as well. Okay. All right, so at this point, this is a good point. We should probably get this saved up. Okay, I'm going to slide this right over here to the right, and now I'm going to be pulling open my change parameters. Okay, so I'm going to go ahead and condense this down just a little bit where you can kind of see this sort of happening on the fly. All right, so if we've done this correct, it's going to have a good relationship between all these parameters, and we're going to see the real importance of why we use parameters. All right, so our width right now, let's just say we don't like that width of 5 inches. We want to double it to 10 inches. We hit 10 and hit enter, and we can see this thing has now grown, double on its width. And since we have percentages for our height and our depth, we're going to see that that is also proportional with those. All right, hey, maybe the thickness isn't thick enough. Now maybe we need to increase that. Let's go up to a full 1 inch for our thickness on our material. We can see that the MDF is now switched up on that. Okay, maybe our axle hole diameter, maybe we've increased that to a 1/2 inch. We can see that that changes on the fly, and we can also see that our rod guide hole diameter, maybe that's not big enough. Maybe we need to increase those by 1. All right, so it really does have artificial intelligence, and we can see how all these parameters can reference each other, and it can do some great things. The important thing here is that we are no longer having to go in and change sketches and features and all this information when we can set this all up within parameters. It's actually pretty amazing. So I'm going to switch all these back to where they were. So our width was 5, our thickness was at 1/4. Our axle hole diameter was at 1/4, and then our rod guide hole diameter was at 1/2 inch. Okay, so we're all set there. All right, so what you're going to be doing now is you're going to start creating some other parts that we're going to use within our automata. And those parts are going to be the rod guide, the crank handle, the follower, and then the shaft collar. But you're going to be doing this using a top-down approach. All right. So what that means for us is that we are going to have to go out and look at the working drawings we have within Google Classroom. And when we go into Google Classroom, underneath classwork, underneath automata, okay, you're going to start seeing all those different working drawings. So shaft collar, that's a pretty simple one. Let's just take a look at that. Okay. So a couple things just to note real quick. We have a construction note down here. The material that we're going to use for our shaft collars, and actually it's going to be for our cams, it's going to be for our crank handle, for all those, is actually going to be a finished plywood. And the plywood itself is going to be 0.1875, which is 3/16. Okay, because we're simply laser cutting those. We're giving those to you guys to actually create your prototypes. The appearance on this is going to be a 3D maple quilted semi-gloss. I'll show you where that's at here in just a little bit. So really, if you kind of think about it, since our shaft collar is going to be connected to our axle, all right, we already kind of know what that is. That's our axle hole DIA. That's that parameter. And since we're going to have parts that are made of plywood or laser cut from plywood, we can actually set up a new parameter because they're all going to be using the same exact plywood, which is 3/16 or 0.1875. So we'll set up a new parameter for that. Really, the only thing that we don't know is going to be the diameter of this actual shaft collar. That's 1 inch. That's pretty easy. Okay, so let me show you how this works. So if we go into Fusion, the first thing we're going to do is go back into Modify, go into Change Our Parameters, and let's go ahead and come up with a new user parameter, because I said, hey, everything that we're laser cutting is going to be out of the same plywood. All right, so I'm going to keep this simple. I'm going to say this is PLY THK. So this is our plywood thickness, and we're going to say this is worth 0.1875. Okay, we want to put that in as an actual number so we could actually change it if we need to. Okay, the comment on this one is going to be plywood thickness. Okay, and there you go. That's what your user parameter is going to be for your plywood thickness. Okay, we say okay to that. We're going to go ahead and say okay. Okay, so there's a couple ways we can do this. All right, we're going to build a shaft collar first. So let's go ahead and let's just create a sketch here. I'm going to just pick this face. All right, so we know what the diameter was. That was 1 inch. So I'm going to apply 1 inch diameter. And now I'm going to create a hole that's concentric. It's going to share the same center point. And I'm just going to type in, this is worth my axle hole DIA. Okay, so that's in there. I'm going to go ahead and finish the sketch. Okay, look at this in an isometric view. And now I'm going to go ahead and extrude this. All right, so our extrusion on this one is not going to be THK. It's going to be PLY THK because it's made of plywood. And don't forget to make this a new component. We say okay. Now this is when we can come over here. We can give this a name like shaft collar. And we can go to shaft collar. We can go into our physical material. This is going to be finished plywood. So I'm going to come down here and find wood. Okay, and you're going to be able to see finished plywood. There it is. I'm going to drag it on top. We have it. And now we can come out here, go into our appearance. All right, and now we're going to come in, look underneath our finished wood. I think it's right here. So this is our 3D maple quilted semi-gloss. Drag that right on top. We have our appearance. That looks good. All right, so remember, we haven't done anything with it, so it's able to float. All right, and the actual assembly itself, all right, there's going to be 2 of them. So at this point, if you want to, you could simply just go ahead and do a copy. Okay, do a paste. Okay, and just send that back. All right, so we got it. All right, so that's the first way we could do it. The second way we could do it, it just cuts out one step. It's nothing really groundbreaking, but it is kind of cool to see. So check this out. We could say create a sketch right here on this face. When I zoom in here, I'm going to draw a circle, but I want it to be right at that center point, and that's going to obviously be a diameter of 1. Instead of drawing the actual circle, what I could do is I could use or reference geometry that already exists. So I'm going to say project. I'm going to come in here and find the edge of that hole. I'm going to go ahead and say OK, and then just simply finish the sketch. Okay, now what I can do is an extrude, pick on this profile. Remember, this is going to be PLY THK, and don't forget, this needs to be a new component. Okay, I'm going to say OK on that. I'm going to pull this off, and then obviously you know the rest. We could go and we could change the name of this to shaft collar, do the material and the appearance. Okay, take care of it. All right, so that's another way to do it. Now, if you're looking at that, you're like, hey, you never actually put in the axle hole DIA parameter. Well, it's referencing this, which does. So that means if we do come out here and do a change on this, and I'm going to do it right now, we go into our change parameters. If we come into axle hole DIA and we say switch it to 0.5 and hit enter, we are going to see it changed it here, which is what we put in manually, and then here, which is what we reference, which is pretty cool. All right, so it will update with it. All right, if you're referencing that geometry. So it's just something that's kind of cool to use, project with, and that's something that can help you down the road. All right, so what that means for your assignment is that you got shaft collar that you have to create, and using a top-down approach, follower for a top-down approach. You're also going to be creating the crank handle. And you're also going to be creating a rod guide. I don't know if I've said that one or not. So you have to start thinking about your parametrics, all right, your parameters that you're going to start loading in. So your crank handle is going to have 2 holes in it. One's going to be on the axle. One's going to be hosting a crank handle peg. Guess what? It's going to be the same exact 1/4 inch rod that we're going to use for the axle as well as the crank handle peg. So what does that tell you about the parameters? Use axle hole DIA for both of those holes. Okay, when you're creating the rod guide is going to go into the rod guide hole, which is on top of your box. You could reference the geometry, do it that way, or when you go to create your rod guide, you can simply use your rod guide hole DIA parameter. All right, so you can use all that stuff so this will size if you were to make any adjustments. So there you go. That's the first part of creating our Automata project. That's just showing the top-down approach. That's how you create the box, and then that's how you're creating parts on the fly. How do you know if you're doing the top-down modeling approach correctly? Well, if you can see right here, since I've been creating this one, which is one I'm currently in, all right, you're going to see that there are no parts underneath it. Okay, that's bottom up approach. All right, top down means all these parts are embedded right here within this design. All right, so there you go. Good luck with Automata. Have fun with that. All right, and good luck making that very, very smart assembly. And it's really shown a mastery of skills. All right, it's great stuff. So good luck.